Hello guys, welcome back to my YouTube channel DESI ASTRO, and in this uh, video of a special relativity given by Einstein in 1905, we will be studying the very basic of Galilean transformation equation. So basically this transformation equation relates the quantity measured in a frame with respect to each other. So you can see that we have two frame. You can see that we have two frames, say S and S prime. We have two frame S and S prime, and these are like inertial frames. These are inertial frame, means they have no acceleration, implies that no force, so their velocity is constant or zero. So now we have two frame S and S prime, and they have origin O and O prime, and observers are sitting at the origin. So at t equal to 0, O and O prime coincides. Now suppose S prime starts moving with respect to S in positive x direction. So at time t, at time t, suppose that we have a particle say P having mass m and having coordinates with respect to O, x and t, and with respect to O prime it has coordinate x prime, t prime. So now our job is to relate S prime frame, uh, S prime and at point P. So you can see that for time t, the distance between O and O prime is Vt, and the particle has coordinate x prime with respect to O prime and x with respect to O. So you can write from O to O prime, you can write x prime equal to x minus Vt, and then we have y prime equal to y, because there is no motion in y and z. So v is like, you have your v, so v is like constant, and this is only in like x direction, so vx equal to v. So, and then as we know that in classical physics time is absolute, so this is your transformation equations. You can say your time is absolute, and you can also write that no motion, in yz direction. So these four sets of equations are called direct transformation equations. Now, what we'll do, we'll we'll try to uh, find the inverse of this transformation. I mean from O prime to O. Okay, so inverse inverse transformation. So inverse transformation. So what we'll do, we'll look from O prime to O, and then for finding inverse transformation, I mean you are looking from S prime to S frame. So for that, what S prime observes, S prime sees that S moves with minus v velocity in minus x direction. So what will be our transformation equation in that case? So in this case, it will be x equal to x prime plus vt, your y equal to y prime, z equal to z prime, and t equal to t prime. So basically what we have done here, see the law of Higgs is like same in like all frame. So we have just replaced x to x prime, y to y prime, and z to z prime, and t to t prime, and v to minus v. So this way you can create your inverse. So for inverse transformation. Now this is like regarding the position of the particle of mass m, and so now you can also find velocity transformation equations. Velocity transformation. So as we know that we have x prime equal to x minus vt. So for velocity, what we'll do? We'll do dx prime by dt equal to dx by dt minus v. So v is our constant. So d by dt. So what it will give? It will give that. So we called it dx by d by dt prime of x prime equal to u prime equal to u minus v. So this is how the velocity in s and x prime are related with respect to object. So this is your like velocity subtraction and now so similar way you can also like go back and you can like transfer, you can also write equation, so call it equation 2, and then you can also write u equal to u prime plus b, I mean, so this is like you basically your velocity addition. Because of transformation, now you can like find relation between your acceleration quantities. So acceleration. So for that we have u prime equal to u minus v. Maybe you can write plus minus to combine both. But this will not work. So keep it only plus. So now take one more derivative. Du prime by dt prime equal to du by dt plus dv by dt. So this goes to 0 as v is constant. V equal to constant. So what will be happen? This will called a prime and this is a. So if we multiply with mass m, then f prime equal to f. So you got thus you can say that if you have a prime equal to a, then you can claim that acceleration is invariant in Galilean transformation equation. Okay, so and also like this is property of a inertial frames that I mean what one observer see, like it is equivalent to other frame, and it is unlike your non-inertial frames in which like you need to add a pseudo force. So in inertial frames, everything is same for both observers. There will be no difference. So uh, conclusion. Okay, so what we have done, we have related O to O prime for a particle of mass, and this S prime moves with velocity v, and so we have got direct transformation x prime equal to x minus vt and x equal to x prime plus vt prime, and here is like t equal to t prime, and there's no motion like y and z. So and also for velocity you have u prime equal to u minus v and u equal to u prime plus v, and for acceleration a prime equal to a implies that f equal to f prime. So basically force is same in both inertial frames. Okay, so what we study about inertial frame moving with respect to each other is that what we measured in both frame will be same. I mean like the the force on the object will be same, and in this case your acceleration is invariant under the Galilean transformation equation. So I hope you have got the idea of this transformation equation, that what we have done. So let's revise once again. So basically we have like two frames moving with respect to each other. with velocity v in positive x direction, and we have like O and O prime origin. And here we have particle of mass m having coordinates xt, x prime t prime with respect to O, and we have tried to find out a relation between both frames for a particle at p. So for that we have tried to derive equations uh, like direct transformation equation x prime to x, and then we have again went to like its inverse transformation equation of Galilean, and we have also found the velocity transformation equation which gives us u prime equal to u minus b and u equal to u prime plus b. And we have also found out that acceleration in case of Galilean transformation equation is invariant. So basically it implies that force in both inertial frames are same. So this is unique about your inertial frames, like two observer measure the same force for a particle. So I hope this has gives some overview of uh, transformation equation in classical physics. So thank you, and I will be uploading more videos on special relativity. So till wait for that. Thank you.